According to a recent model of the very initial cosmos, the graviton, the quantum field, inundated the world with dark matter before regular matter even had a chance to form. The concept might provide a method to solve two of current cosmology's largest unsolved mysteries, the nature of dark matter and the history of expansion of the universe. Do you think the origin of dark matter is gravity itself or otherwise? Well, we are going to see that in this video. If you are new here, we publish new content every day, so be sure to subscribe to Future Tech and ring the bell to get notified about any of our recent videos. Let's go through the origin of dark matters. So grab a seat and stay tuned. Numerous philosophers of science believe that when the cosmos was very young, it went through a phase of extremely fast development known as inflation. This inflationary period was important to the universe's future history because it changed microscopic quantum fluctuations in space-time into the seeds that would one day become stars, galaxies, and clusters. The real inflation event is quite obscure. Scientists, for example, don't know what caused inflation, what propelled it, how long this lasts, or when it ended. The universe was significantly bigger at the completion of inflation than it had been previously, but it was also considerably emptier, since all of the former components of the world had just been tossed far apart. There was only one thing left, whatever had fueled inflation in the first place, but had ultimately run out of steam. When inflation ended, it caused the formation of all existing particles. So, most likely, the same event created dark matter. Scientists today aren't sure what dark matter is composed of, but there's a lot of evidence suggesting it's some type of new, undiscovered particle. This particle, whatever it is, accounts for more than 80% of all mass of the universe. This lack of invention of dark matter has a particular problem for the inflation theory, since if dark matter doesn't communicate with regular matter, there's no motivation for the inflation to generate dark matter with normal matter in the initial world. Scientists used an instrument designed to look for dark matter, the Xenon 1T, which is the most mysterious particle known to man, to analyze a method that involves more than 1 trillion times the age of the universe to complete. The researchers weren't just looking at a single xenon atom with a magnifier expecting to observe it disintegrate. Because of all the liquid xenon, there are practically incomprehensible amounts of xenon atoms in Xenon 1T, thereby allowing the scientists to watch trillions of atoms. In December 2018, Xenon 1T was shut down for a major upgrade designated as Xenon NT. The newest detector will be significantly larger and carry 3 times as much liquid xenon, making it even more responsive to uncommon events and perhaps the detection of dark matter particles. The radioactive decay of Xenon 124, a form or isotope of the element xenon, a colorless, dense, odorless gas present in minute amounts in Earth's atmosphere, was detected by an international team. Experts originally projected that the half-life of Xenon 124 would be roughly 160 trillion years, given it half the time of a radioactive material to decay. However, there has been no proof of this mechanism until today. According to Ethan Brown, in his statement, he said that this process is seen as the slowest, longest thing that has ever been observed. Yet, the chances of witnessing any one disintegration of Xenon 124 are negligible, since the periods required, according to Brown, are well over 1 trillion times longer than the entire history of the universe. There must be a good amount of decays to be measured, and the shorter the process, the lesser decays there are. Brown still said, because decays occur on such a lengthy time scale, we get around this by using a large number of Xenon 124 atoms in our device. Even so, it took a year of searching to find a relatively tiny number of decays. Aside from having a large amount of xenon atoms, the researchers seek to guarantee that the detector was located in one of the cleanest areas on Earth to minimize any outside influence, like as cosmic rays. In line with different scientists, proof for the decay comes from the first visual examination of a physical event known as neutrino double electron capture in Xenon 124. This is the process by which a proton inside the nucleus of a xenon atom transforms into a neutron. This occurs when one electron is pulled into the nucleus of most atoms that suffer radioactive decay. However, in order to become a neutron, A proton in a xenon atom must take 2 electrons, hence the term double electron capture. Brown said in a speech, "This can occur just when 2 electrons are right opposite to the nucleus at the same time, a rare thing doubled by another rare thing, rendering it super-duper." Still, the physicist's proposal is fascinating because it allows the ancient world to develop huge amounts of dark matter and to never interact with regular matter again. Does this dark matter of a thing exist? So how do scientists know it exists? Is it acceptable? For more than 50 years, scientists had first theorized dark matter, which is supposed to be the most popular type of substance in the world. Regardless, the scientists had no idea because no one had seen it or generated it in the lab. The scientists fine-tuned their theory to get the correct quantity of dark matter required by measurements of the universe. It is, nevertheless, a theoretical work. Most importantly, scientists don't know how gravity interacts with particles. A fundamental investigation of our neighboring galaxy Andromeda's rotation by astronomers Vera Rubin and Kent Ford in the 1970s showed an unexpected disagreement among both the theory and evidence. In line with the greatest gravitational explanation for these sizes, Newton's law explains that stars and gas in a galaxy should rotate slower and slower the more they are from the galaxy's center. Because the majority of the stars will be at the center, there will be a significant gravitational force there. To explain this abnormality, it was claimed that the galaxy must be contained in a massive halo of dark matter. This unseen mass network with the outer stars via gravity accelerating their velocity. When there is extremely tiny acceleration, like near the edge of galaxies, Newtonian rules may behave significantly in another way. This modification was entirely consistent with the measured galactic rotation. Nonetheless, scientists now strongly embrace the so-called dark matter idea. This viewpoint is so deeply rooted in physics that it is sometimes referred to as the standard model of cosmology. However, if the two conflicting hypotheses of dark matter and modified gravity can both explain galaxy rotation and other abnormalities, one would question why we should choose one over the other. Why did the science world single out the dark matter theory over reformed gravity? And how are we to know which of the two explanations is correct? Well, philosophy is here for our rescue. Philosophers attempted to characterize any case in which the existing facts may be insufficient to identify what beliefs we should hold in response. For a long time, philosophers of science have been really troubled by this issue. The facts alone cannot tell whether the detected velocities are attributable to the presence of extra unknowable materials or to the fact that our existing gravitational equations are inaccurate in the event of unusual rotation in galaxies. Trying to explain all of the observable verification for dark matter, sometimes with incredible success throughout previous years. Still, the dark matter idea remains the preferred explanation of various physicists. Why? As a result, scientists still hunt for further evidence in various situations that may finally resolve the question. Finally, philosophy cannot tell us whether physicists are correct or incorrect concerning the reality of dark matter. It can, however, tell us if physicists have solid grounds to rely on the modified gravity facts, and what it takes for modified gravity to be as widely held as the dark matter. We don't yet have definitive answers to these issues. More work from the scientists will give us a more accurate conclusion. We have come to an end of this rare event on how the different scientists hunt for dark matters. And let me ask, do you think there is another proof that it exists? Or the evidence is all here in this video? Don't miss this opportunity to drop your answers in the comment area too. If you found this video helpful, make sure to like the video and subscribe to Future Tech, where you will find quality information about technologies. Click on the bell icon so you get a notification whenever we upload.